Okay, in this video, we will learn how to graph exponential functions by using transformations, okay? And before we do that, let's talk about two terminologies. And let's do page number 7 on this handout, and number 9 is talking about x-intercept and y-intercept. What is x-intercept? We haven't seen this term a few days ago in test, right? What is x-intercept? That is x value when the other variable is 0. What is the other variable? Y. That's right. Y is 0 and you get x value. That's called the x-intercept. If I graph it and I can see x-intercept on the x-axis. Okay, so the point is cut through the x-axis, that is called x-intercept. Intercept means cut through. So let's see, if I do number 9a and x-intercept is x value when y is 0. Where is y in this problem? There is no y, right? The function value itself is y, so we will equate it with 0 for that. So we can solve it. Can we solve this equation? What would be the first step? Let's do all the way backwards of PEMDAS, okay? So we add 6 on both sides, and then we can isolate the exponential part. And what would be next step? 2 to the x will be left alone, okay? So to do that, I need to divide both sides by 3. So 6 divided by 3, we get 2. Now let's compare left and right hand side. What would be the x value making this statement true? Power of 1, right? So x must be 1. So that is x-intercept. So x-intercept can be found by setting up the equation as 0. So let's do next one. Function value itself is 0. And can I solve this equation? Let's isolate the variable part. The variable is in the exponent, so we will do subtraction or addition first, okay? So let's subtract 9 from both sides. So there will be negative 9 equals to negative 1 times 3 to the x power. Can you get rid of negative 1 from exponential form by doing division? Yes, let's do that. What do we get? There will be positive 9. Can I rewrite this number 9 as exponential form with the base 3? 3 to the second power. So compare left and right hand side. You have the same variable at the exponent location with the same base 3. So x must be 2. Okay? So that's how we solve exponential equations. And we can verify x-intercept, y-intercept from the graph, but we try to do algebra a little bit here, okay? Next one, what is y-intercept? Y-intercept is y value when x is 0, okay? So for a question, you equate this r of 0 as y, that is y value, okay? So we plug 0 instead of the function, and then we will evaluate it. 3 times 2 to the 0 power, subtract 6. I need to do power first. Anything to the 0 power is defined as 1. So 3 times 1, and subtract 6, and your y-intercept will be negative 3, okay? That is y-intercept. Similarly, for the other problem, you do y value. You are looking for y value, so let's plug 0 in the function, given function. So instead of x, you plug 0, and you can evaluate it. That is called y-intercept. So negative 1 times 1, that is negative 1, plus 9, and we get 8. All right? So this is y-intercept. So we can find x-intercept, y-intercept by using the functions. And you sometimes graphing those points are very important, so you can use those as a reference point, okay? And today we will use transformation rules for graphing. So x-intercept, y-intercept, you can plot those on the graph if it is necessary. All right, now let's see question number 10. And we have 4 questions. And we will talk about transformation rules, and then we will graph it. Okay, let's do number 10A and number 10D with me, okay? And I'll do A and D. So now let's see. The parent graph is shown in light gray color here on the graph. Use the transformation rules and then draw a given function. So let's look at the given parent function, 2 to the x. It is changed. All right, let's compare it and then let's see transformations. What transformation happened here because of x minus 2? To the left or right? Yeah, we do backwards, okay? To the right 2 units. Because of number -6 in the new function, what happened in the transformation? Going down 6. By using this transformation, we can graph easily, okay? So because of this down 6, if you recognize there is a horizontal asymptote here on the parent function, that will also move, right? By using right 2, it never goes anywhere because both the direction is aligned, okay? It goes infinitely. So bring down 6, where does it go? Horizontal asymptote is going to be y equals -6. So let's draw horizontal asymptote at -6, like this. And now I need to move all the points from the original function, parent function, using this right 2 down 6, okay? How many points are good enough for drawing a curve? 3, so let's see which 3 are good points. I'll use the point on the corner of the grid, okay? So I'm going to use these 3 points and I'll move them. So right 2, 1, 2, down 6. 1, 2, 3, 4, 5, 6, plot the point. And then next one in this location, and next one is in that location. So you're moving all the points by using the same rule. Right 2, down 6. And then connect the dots with nice and smooth curve, that direction, and then you can complete the graph, okay? And my other parts of the graph may not exact, but I'm using 3 reference points which are exactly on the corner of the grid, okay? So those are reference points. That's how we graph it. Now let's look at T, and then let's identify the transformation rules first, and then let's graph it. What transformation rule happened on T? Let's compare the equation. 3 to the x power is the parent function, and 3 to the -x power plus 2. Up to from plus 2, that's right, up to. So horizontal asymptote is going to be at y equals 2. Because of -x, what happened to the graph? -x means left goes to right, right goes to left, okay? So we change x coordinate, moving left to right in opposite direction, so this will be reflection. Reflection along which axis? Left to right changes, so along y-axis. Okay, reflection along y-axis. So let's graph this. Horizontal asymptote is at 2. So let's draw the helping line. This is not a part of the graph, but I want you to graph horizontal asymptote before you graph the original graph. And now let's move the points. This point and this point, and not a good point. Is there any good point I can graph? Okay, let's move it. It's in the middle. All right, up to, and then I need to reflect it along y-axis. So this one, up to and reflect it, it's not going anywhere, right? left to right. It's on the y-axis, it stays there. And this one up 2, and then left to right swap, and then this will go this direction. Is it confusing? Can I use different colors for all three? And this is the new location, and this is the new location. Okay, first top 2, blue goes to purple here. And now let's move this one up 2 and the other side, because it is reflecting along y-axis. Did I move 2? No, it's not there, right? It should go up 2. 1 and 2, and then opposite direction, so that will be here. It should be above this horizontal asymptote, right? Did I move everything 2 points? 1, 2, okay, here, 1, 2, yes. Now let's connect the dots. This is going to be decreasing, not increasing, because we are flipping along the y-axis. So this is the graph of the function t after transformation.